Hello, welcome back to another video. We're talking about end behavior. So this is day two, kind of picking off of what we discussed in class. So I know in class we kind of left off, which is like, whoa, what are we talking about? What did we just do? Well, today I hope to clear all that up. So I don't know what this background is, but today our objective is just to determine the end behavior of polynomials, giving a graph or an equation. So if I give you a graph or an equation, I want you to be able to determine the end behavior. Now, a little recap again. Last class, lovely groups, beautiful groups here. Our goat that was for some reason buying. Uh, what is this? The boats or the swimming pools with Willie, and then Daryl Dawkins, as you know, as well. So last class, I just gave you here's a bunch of equations, here's a bunch of graphs, go. And we weren't really sure what we're kind of doing here. And yes, we did discuss even and odd functions, primarily with symmetry. But really, we're going to something different now. So with this here, there was not a wrong answer. There was not a right answer. However, our goal is to figure out what is all of this. So quick little reminder on vocab. When I say the word leading coefficient, I am talking about the coefficient on with the term of the highest degree. So for example, if I say, hey, f of x equals 5x to the fourth plus 6x minus 3, that has a leading coefficient of 5. Why is it 5? Because x to the fourth is the biggest of all of them. It was the biggest degree of all of them. And then the coefficient in front is my leading coefficient. So while yes, 5, 6, and negative 3 are coefficients, well actually negative 3 is not a coefficient. While yes, 5 and 6 are coefficients, 5 is my leading coefficient. Same thing if I gave you 5 plus 6x to the 7th minus 8x to the 3, the 8x third, that has a leading coefficient of 6. Just because this is not in front does not like disqualify it for not being leading coefficient. That was a confusing sentence. Um, it's the coefficient on the term with the highest degree. In this case, my highest degree is 7, therefore 6x to the 7, with 6 being my leading coefficient. That's important, especially for today. But first, I'm going to ask like a lot of hypothetical questions. So I want to assume you're there in your household, just intently listening, totally paying attention, and also willing just to respond back in person out loud, even though maybe people around you may think you're weird. Respond back in your head. I don't care. But little just hypothetical question. Let's say I took that challenge, that little group activity. I did it by myself. And I was like, you know what? Here's what I'm going to do. I'm going to group all of these equations together because I know that these equations are going to have both ends of the graph pointing up or pointing down, one of the two. And I was like, you know what? I'm going to group these equations together because I know one of the ends are going to point up and the other end is going to point down. Notice on this one, I didn't say, hey, the right end or the left end is pointing up or down. I just said one of them is going to point up, one of them is going to point down. Not many options. So then question for you. Again, hypothetical question, answer it out loud if you like. What do you notice about the highest degree with these equations and the highest degree with these equations? Correct. Well, kind of. You were there. Um, the highest degree on all these equations, it's an even number. And the highest degree in all of these equations is an odd number. And yes, I know on these two you have to multiply it out. But if I was to multiply it out, I would get like x to the 6. All of these equations have even degrees, the highest being, and the highest degree on this one would have an odd number. So that being said, if I gave you this equation, 3x to the 12 plus 6x cubed, where would it land? Well, 12 is clearly the biggest number there, and 12 is also an even number. So since I have an highest degree, that's an even number, that says it must fall in this category, where with this graph, both of the ends are either going to point up or down. Now in a bit, we'll specify which way it is, But for right now, I know that both of the ends are going in the same direction. I'll emphasize that. Both of the ends are going in the same direction. With even degrees, both of the ends will go in the same direction. As opposed to odd degrees. Let's say I give you 3x to the 15th plus 6x cubed. Well, 15 is my highest degree, and 15 is an odd number. So if my highest degree is an odd number, that means my ends are going in opposite directions. Right now, I don't really know if the right end is going up or the left end is going up. All I know is they're opposite directions. So if the right side's going up, left side's going down. If the left side's going up, right side's going down. So we're going to emphasize right now solely even degrees. When I say solely even degrees, the highest being even. So Sandy, come on, Sandy. Sandy created two groups of graphs on the left, three of them orange, three of them green. Actually, Sandy did a good job here. Why do you think Sandy's separated in that way? Yes, I like your answer. Because three of these are all pointing up, and the three of these are all pointing down. Oh, can I? Cool. Yeah, both are pointing up. Both ends of the graphs in the orange point up. Both ends in the green point down. Now, look at these equations. Okay, so look at all these equations here. Look at all these equations here. What creates that difference? What makes these ends point up and what makes these ends point down? Now, we'll answer that on this next slide here. Again, hypothetical scenario. Me and you are talking back and forth, having a nice conversation. And I'm like, hey, graphs of these equations will either have both ends pointing up, boom, and graphs of these equations will both have both ends pointing down. So if I ask you in this hypothetical scenario in the conversation back and forth, I'm like, hey, look at the leading coefficient. What's the difference between the leading coefficient on this first group as opposed to the leading coefficient on this second group? Again, look at these equations. What's the difference between this first leading coefficient between these leading coefficients? That's good. The leading coefficient, if you notice here, are all positive. And again, as a reminder, leading coefficient is the coefficient of the term with the highest degree. So 6 is my clearest highest degree here. It's positive. 4 is the highest degree here. It's positive. Same thing here. If I was to multiply all this out, I would have 4 as my leading coefficient. As opposed to the second group, leading coefficient, and it's the exact same equation, by the way, except that there's a negative for my leading coefficient. So that says here, this is a really specific category. If my highest degree is even, this will now tell us that if my highest degree is even and my leading coefficient is positive, that means both of the ends will point up. If my highest degree is even and my leading coefficient is negative, that means both of the ends will be pointing down. So if I gave you 3x to the 10th plus 6x, the behavior of this graph would have both ends pointing up. As opposed to this one here, if I had, oh, perfect. If I have both ends of the equation of this one, negative 3x to the 10th plus 6x, the degree is even, and the leading coefficient is negative, that means they're pointing down. Now, I'm not going to do this with the odd just because, as you can see, it's just a lot of me talking back and forth with you. But I love this little sheet because it's going to summarize it. And so when I say degree, I mean the highest degree. Leading coefficient, you know that. I'll give you an example of what that looks like and then what that graph looks like as well. So we just discussed the even part already. We just said, hey, if you have the highest degree even and it's positive, that means both of the graphs were pointing up. Classic example of that. You know it, you love it. Y equals x squared. And I'll draw that in a second. And again, I'm just making these up on the spot. Well, I made them up beforehand, so I have a sticky note right here. I'm cheating. But with this here, again, all this means, actually, I'll do this. Perfect. What this means here is both ends of the graph will be pointing up. With this here, this one's a little bit weirder. Again, this is what the end behavior says, is if we have a leading coefficient that's positive and we have an even degree, both of the ends of the graph will be pointing up. I don't know what's happening in the middle. Clearly two different things happening in the middle, but I know that the end is going to be pointing up. So still on that even degree tangent, what about if it's negative? So y equals, I don't know, negative x to the fourth. I bet I'm freaking out. There's a wasp here. Sorry about that. I had to kill a wasp was getting really close to me. So highest degree if it's even, and the leading coefficient if it's negative. I just took y equals x to the fourth. Y equals negative x to the fourth. And I'll draw this in a second. And I'll say here again, just some random equations that I made up beforehand. Nothing special about them except for a leading coefficient. So for this first one, since the highest degree is negative, since the highest degree is even, and the leading coefficient is negative, that means that here with this graph, both ends are pointing down. Same thing for the second one. If I gave you that y equals negative 6x to the 6 minus 3x squared, don't really know too much of how this looks. I do know that the ends are going to be pointing down. Now, we didn't discuss this because I just didn't want to go through the same thing for odd degrees. But if I gave you an equation like, I don't know, actually, y equals x cubed. And also, y equals x. Remember, that's an invisible, quote unquote, 1 right there. It was an invisible, quote unquote, 1 right there. That means that the highest degree is an odd number, and my leading coefficient is a positive number. So when we have that in that scenario, we get, so if you didn't know what this looks like, I'm going to try my best. That's not bad. That's not bad. We get this. When the leading coefficient of an odd degree polynomial is given, we get that the graph shape is going to have the right side go up to positive infinity and the left side go down to negative infinity. Again, with a positive leading coefficient for an odd degree, the right end or the right tail is going to go all the way up and the left tail is going to go all the way down. So if I gave you an odd degree and a negative leading coefficient, which I don't know, am I creative? I don't think I'm creative. Yeah, I'm not creative. So we'll say here, y equals negative x cubed, and y equals negative x. Whoa. That will tell us here that it's actually flipped. That's not too bad. That says that with my highest degree being odd, and with the leading coefficient being negative, the left side is going to go up, with the right side going down. Same thing, left side going up, right side going down, with the leading coefficient being negative on odd degree. So notice again, these are very specific categories. I have like 4 different scenarios. Let me see here. Quick question. Just 2 questions for you to ask yourself. The graphs of which of the following equations would have both ends pointing downward? So whenever you have like an equation, and we'll do some practical examples. Ones that are found on Delta Math will be on your homework. But with this here, always ask yourself, okay, what is my degree? Is it even or odd? And then what is my leading coefficient? So if we want both ends pointing in the same direction, that means we must have an even degree. So that marks off 2 of them already for me. We're like, oh, okay, that clearly can't be, I guess, f of x and h of x. There's not a, b, and c. Well, left with 2. So both ends are pointing in the same direction. That's what even degree tells me. What about both of them pointing down? That would be the leading coefficient. And if the leading coefficient is negative, that means that both ends are going to point down. So similar scenario, but with a different question. We want the left end to start up at a large positive, then go all the way down with the right end going down. So again, the left end and the right end are going in opposite directions. So opposite directions is at an even or odd degree. Yes, it is an odd degree. So it can't be g of x or j of x in this case. Now, if we want the left end to start up in a large positive and the right end to go down to a negative, the leading coefficient must be correct. It must be negative. Now, I'm saying like, both ends going down, one side going up, blah, blah, blah. There's some notation that we will use to say all of this instead of me having to say those different things all the time. And this notation you will see on Delta Math. However, I'm still jazzed up after killing that wall, so I need to take a break. So I'm gonna bring in a special guest. He's a big hero of mine. Like I look up to this man so much for everything he has done for this country. Like his legacy will always be valued in my eyes, and it always should be valued in the education system. So, ladies and gentlemen, please put your hands together, and then actually clap with your hands, not put them together, but clap for our special guest. Let's bring him in. Hey there, folks. My name is David Crockett. You may recognize me from Texas history, that good old 7th grade class you had to take. Well, folks, I'm here today to help you talk about this notation for end behavior. Now, Mr. Garcia, that's a good old friend of mine. We go way back. He actually helped me talk to Sam Houston for the first time. That big old war general was very scary and intimidating at first. And I used to help Mr. Garcia with his math back in the days, but that's a later topic for a later time now. So you see here, notation for end behavior. That's such a fun little notation that we like to talk about. Now here, I like to see this notation. Oh, you can't see it. Let me move this contraption out back. See, this contraption, I don't know how to work it. Mr. Garcia gave it to me. It's so fancy, so technology-wise. I just want to get my good old Munchkin, my good old raccoon here, and I'm good. So now here, with this notation here. Okay? See this notation? And I'm going to use this little pointer from Sam Houston himself. Uses this on the battlefield. So whenever I say my x values, whenever going to the right, which means they're going to infinity, my y values, or my f of x, is either approaching that positive or negative. Really all depends on what situation you got here. Okay? So let's say here I got an even degree. Okay? So even degree means they both point same direction, and it's a leading coefficient of a positive number. Is it a positive number? Let's do a positive number. So leading coefficient is positive. That means that the x values that are on the right side will go to positive infinity. Same thing for negative infinity. You can't really see that, can y'all? Y'all can see that. Y'all can see that. So the x values, as they go to negative infinity, my f of x values going to go to that negative infinity as well. Again, it's all dependent on what your question is asking. Now, that being said, there's different ways you can do that. Now, oh, look at that contraption. So, that being said, fellas, I got to get going. My good old buddy David Bowie, not David Bowie, James Bowie, I think that's his name was, but his last name is Bowie, and William B. Travis are waiting for me at this little mission called the Alamo. Heard it's a nice little spot, but there's always that Santa Ana that's on the horizon since we're in this war. So hopefully nothing bad happens when I go approach this Alamo. So folks, hopefully I will see y'all next time. Mr. David Crockett out. Man, I'm always so moved whenever Davey speaks. So thank you again, Davey, for coming out. I know you're a big inspiration to me. I hope he's a big inspiration to you as well. I would never want anything bad to happen to him. So safe journeys on your trip to the Alamo. Hopefully it's as beautiful as they say. Go fight that Santa Ana. Yeah. So you there in your home. Wish Davey good luck. We never want anything bad to happen to him. So he was talking about some different notation we will be using. So we're going to use infinity to describe our polynomials for our end behavior. And again, we will be primarily discussing polynomials. We're not really going too much into rationals or really any exponentials or stuff like that altogether. So on that board that David talked about, he said we can use infinity, and it really depends here on our on our if it's odd or even the degree, and if it's a leading coefficient of positive or negative. But this is saying here, as the x values approach negative infinity, so it really means all the x values that's on the left. So the left side of my equation, left side of my graph. As those x values getting closer and closer to negative infinity, as they go to the left, my y values, or my function in this case, is either going up or going down, all dependent on if the degree is even or odd, and if the leading coefficient is positive or negative. Same thing here. As the x values are approaching positive infinity, so as the x's approach the right, or as the tail starts to go to the right, either it will go up or down, depending on what situation I have. So you will literally see me say, as x approaches negative infinity, f of x approaches positive infinity or negative infinity. So let's see some practical examples of this. What is the end behavior of f of x? So we have here this f of x. Don't know the equation. All I have is a graph. Well then, let's just start on the left side. So notice again, there's an arrow right here. That means it's always going to go on forever. So as my x values are going to the left side, that means the x values are approaching negative infinity. So as my x values are approaching negative infinity, my y values looks like they're going up. So it looks like as x approaches negative infinity, f of x is approaching positive infinity. So as my graph goes to the left, it's also going up. What about for the right side? Well, it looks like all these x values are positive. So that's saying as x approaches positive infinity, we're going down. So my y values are going bigger in the negative direction. So that says here, as x approaches positive infinity, f of x is approaching negative infinity. So when discussing the end behavior of a polynomial given a graph or an equation, we're going to say this notation. Yes, you can say, I guess technically you can say the right is going up, left is going down, but we want again that mindset of using the correct notation, saying the correct things. This is big, especially for calculus. But as x approaches negative infinity, f of x is approaching infinity. As x approaches positive infinity, f of x is approaching negative infinity. Question for you on the spot. Ask yourself, is this an even degree or an odd degree? Even degree or an odd degree? Correct. It is an odd degree. Now ask yourself this, is the leading coefficient positive or negative? And I'll go ahead and write that here. So we have an odd degree. That's how you spell degree. And then the leading coefficient, ask yourself, is that positive or negative? Ooh, you are correct. It's going to be negative. Perfect. So let's look at this next one here. And behavior of this function, f of x, is this equation. Don't really know what it is, but I have a graph here. Okay. So start on your left. Doesn't really matter what side you start off on. I tend to start on the left, you know. So as my x values are approaching negative infinity, my y values, or f of x in this case, are approaching, correct, they're approaching negative infinity as well. As x approaches negative infinity, f of x approaches negative infinity. Let's look on the other side of our graph. As our x values are getting bigger, what's happening to the y values? You are correct indeed as well. They're still approaching that negative infinity. Ask yourself that same question from last time. Okay, even degree or odd degree, they're both going in the same direction. That means, yes, we have an even. And remember, when I say degree, I'm going to refer to the highest degree. Okay, the highest degree of my polynomial, whatever that is. The highest degree is an even number. And then here, since they're both going in the same direction, that means we have an even degree. But since they're both going down, that means the leading coefficient is, yes, negative. Now, those was graphs, and those are kind of easy to see. What about with an equation? Okay, so with this here, an equation, f of x is negative 10x squared plus 70x minus 100. What is the end behavior? So I always kind of like to start off with the degree and then go with the coefficient. So my highest degree in this case is a 2. I mean, this has a 1 right here, and that doesn't have a degree with it. So technically, you say, no, x to the 0. You can technically say that as well. But with that being said, 2 is my highest. Okay, 2, in case you didn't know, is an even, I almost said odd number, is an even number. So that means my tails or my end behavior is either going to both point up or both point down. Since it's an even degree, both pointing up or both pointing down. Check the leading coefficient next. Since my leading coefficient is negative, that says that both of my tails are going to be pointing down. So if it helps you, you can like draw like a quick sketch, because from there you can say out like your actual notation. So as x approaches negative infinity, f of x is going to also approach negative infinity. And as x approaches positive infinity, f of x is still going to approach negative infinity. I don't really know how this graph looks like. It's going to look something similar to this, solely because it's the highest degree is 2. But I don't really care what it looks like the middle part. All I'm caring about is the tails. Next question here, I believe this is the last one. It's a terrible equation, isn't it? I'm about to read it out loud. Ready? f of x equals 42x to the fifth minus 231x to the fourth minus 966 x cubed minus 7,840 plus 2,772 x squared plus 3,192 x plus 7x to the 6. Okay, ask yourself, highest degree, is it positive? No, it's a positive. Is the highest degree an even number or a negative number? Well, off the bat, I want to say, hey, clearly this is the highest degree, but don't forget about this 7x is 6 at the end. So x to the 6 is an even number. That means both ends are either going to point up or down. It's all dependent on what the leading coefficient says. Again, the leading coefficient is not 42. All right, the leading coefficient is not 42. Just because it's out in front does not make it the leading coefficient. The leading coefficient is a coefficient of the term with the highest degree, which would be 7 in this case. Since 7 is positive, that means both of my tails are going to point up. So with that being said, as that is incorrect, let me fix that. Because as x approaches negative infinity, f of x should approach positive infinity. And I wonder if I did the same thing on the next one. Perfect. Maybe when I made this, I probably saw that the x to the fifth was the highest degree. Probably that's what it is. But as x approaches negative infinity, f of x should approach positive infinity. And as x approaches infinity, f of x should approach infinity as well. The reason why, again, this graph looks something like this. I don't know what the middle looks like because it's just a mess happening here. But I do know that the tails will go in either direction, or will go in both of the same direction. End behavior, this is really the farthest we will go with end behavior. We're not going to talk about like multiplicity or kind of graphing polynomials, just giving an equation. We won't go that far in depth, especially because we're almost out of time. But if you have any questions, please let me know. I'm sorry this video was posted so late. A lot of just different technology issues were happening behind the scenes that were out of my control. I wish I could control, but that's life. So if you have any questions, let me know. If not, I will see you in class on Thursday.